Everyone will tell you the biggest star in the universe is UY Scuti. They're wrong, and the real answer is so large it barely makes sense. By the end of this, you'll see a star so vast that light itself needs nearly a full day just to travel around it. Why our entire sun is effectively invisible beside it, and the unsettling reason a star this size is already dying. It's called Stevenson 218, and it should not be possible. To feel this, you first have to respect our own sun. It's a star so large that about 1.3 million Earths would fit inside it. Standing next to the sun, Earth isn't a planet, it's a grain of sand. Hold that image, because we're about to make the sun itself disappear into nothing. To get there, we go in 3 steps. The star everyone names and why it's a lie, the real record holder, and the disturbing thing it tells us about how giants die. For years, the title of largest known star belonged to UY Scuti, clocked at around 1,700 times the width of the sun. Documentaries crowned it, textbooks repeated it. There was just one problem. That size depended entirely on how far away it was, and nobody had measured that precisely. Then the Gaia Space Telescope did. It mapped the real distance to over 1 billion stars, and UY Scuti turned out to be far closer than assumed, which meant it was also far smaller, shrinking on paper to a fraction of its legend. The champion was dethroned by a single accurate measurement. So if it isn't UY Scuti, what is the real largest star we've ever found? It's called Stevenson 218, a red hypergiant buried in a star cluster about 20,000 light-years away in the constellation Scutum. Its radius is estimated at roughly 2,150 times that of the Sun. Let that sit. Not 21, not 200. Over 2,000 suns lined up across its width. By volume, you could pour nearly 10 billion of our suns into it and still have room. There is no human frame of reference for an object this size, so let's build one anyway, because the next part is where your sense of scale completely breaks. Put Stevenson 218 where our sun is right now. Its surface doesn't just swallow Mercury, Venus, and Earth. It keeps going. It engulfs Mars, crosses the asteroid belt, devours Jupiter, and its glowing edge finally comes to rest somewhere past the orbit of Saturn. Everything you think of as the inner solar system would be inside this single star. Light, the fastest thing that exists, crosses our entire sun in about 4.5 seconds. To travel all the way around Stevenson 218, that same light would need close to a full day. And if you somehow flew a passenger jet around its edge at 900 kilometers an hour, you would not finish the trip in your lifetime or your grandchildren's. It would take more than 1,000 years. A star this impossibly large should be the most permanent thing imaginable. It's the opposite. Here's the cruel rule of the cosmos. The biggest stars live the shortest lives. Our sun is middle-aged at 4.5 billion years and has billions left. A hypergiant like Stevenson 218 burns through its fuel so violently that its entire life may last only a few million years. A cosmic blink. It is already near the end. Stars like this fuse heavier and heavier elements in a frantic, losing battle against their own gravity. And when the fuel finally runs out, the core collapses in less than a second and the star detonates as a supernova, briefly outshining entire galaxies. The largest star we've ever found is also one of the closest to death. But there's a twist that makes even this uncertain, and it's the same trap that fooled us about UY Scuti. Every size you just heard rests on the same fragile foundation. Distance. Stevenson 218 sits 20,000 light-years away, wrapped in dust, in a crowded cluster, which makes pinning down its true size extraordinarily hard. Its measurements carry error bars hundreds of times the width of our sun, and some astronomers think it too may eventually shrink, exactly as UY Scuti did once we looked closer. So the honest truth is uncomfortable. We crown a largest known star, but the title keeps changing as our instruments improve. We are not measuring a fixed record. We are measuring the current edge of our own ignorance. And that edge hides something far stranger than a big star. Because when a star this massive dies, it doesn't just vanish. Its collapsing core can crush itself into something the size of a city, yet so dense that not even light can escape, a black hole. The largest star we've ever found is, in a sense, a black hole waiting to be born. which leaves a question that's almost too big to ask. If a single dying star can fold itself into a point where the rules of physics stop working, then what is the most extreme object hiding in the universe? The one that doesn't just bend space, but breaks it?